Today we will discuss about thermodynamics. Here, the word thermodynamics is derived from the word thermo, which means heat, and dynamics, which means motion. So, in this chemistry, we will discuss about the motion of heat. So, we can say that it is a branch of chemistry which deals with the study of motion of heat energy in a chemical reaction. Specifically, ଆମେ ଗୋଟେ chemical reaction ରେ heat energy ର motion ବିଷୟରେ ଏଠି discuss କରିବା. Chapter start କରିବା ପୂର୍ବରୁ we will discuss about some fundamental terms जोटा कि हमर electronic chapter रे दरकार पड़िबो. Let's start the introduction. So we will start with the term system. Now, what is system? It is a part of universe which is being used for the study purpose is called system. Now consider karo, I have drawn a stadium and this is the region where game will going on. So here we can say there are so many players playing and here are the for audience. Now we can see it is the total part of the stadium. This part of the stadium is used by players for the match. Stadium ro a part players माने use करूछंती for study बा game purpose है. जेहेतु ए part टा से माने use करूछंती for them this part is the system. तांको पाई ऑडियंस माने होचंती सराउंडिंग. तो सिस्टम को छाड़ी देले आ जहां भी रेस्ट रहिला that is called surrounding. तो सिस्टम को हम केमिति डिफाइन करबा? It is a part of universe which is being used for study or research purpose is called what? System. Then what is surrounding? The remaining part of the universe which is not being used for study or research purpose, that is called surrounding. Now audience और players मान को भीतर गोटे differentiate अच्छी गोटे region अच्छी जे separate करूची separator. That separator is called boundary. Now the separator or the region which separates the system from surrounding is called boundary. So this is our system, this is our surrounding, and this is our boundary. Now if we will discuss about boundary, boundary is of two types, that is real boundary and imaginary boundary. Now what is real boundary and what is imaginary boundary? Now जति आमे कोनोसी बाउंड्री को देखि परिबा, फील करि परिबा, टच करि परिबा, then we will say it is a real boundary. जमति this room I am teaching you in this room. So this room is separated from another room by some wall and that wall can be seen, touched or felt by me. आमे जो गोटे रूम रो आ गोटे रूम को सेपरेट करूचे, गोटे कांथ अछि से कांथ को हम देखि पारुचे, टच करि पारुचे, फील करि पारुचे. That's why it is called real boundary. But when we are seeing atmosphere on the hydrosphere, समुद्र ऊपर वायुमंडल अछि, they are separated. Water is separated from air, but we cannot see the separator which is separating from each other, separating them from each other. That separator is called what? Imaginary boundary. We know that there is some kind of separator which is separating the hydrosphere from atmosphere that cannot be seen, but we can feel it. That type of boundary is called imaginary boundary. Now we will proceed further. We will classify different types of systems. Classification of systems. One is open system, closed system, isolated system. Normally system रे हमें दुईटी जिनस कथा डिस्कस करबा. One is mass of the matter and energy. Now consider I am taking a beaker. Now see, मुझे ओपन बीकर रे किछि वाटर नउछि. इनिशियली वाटर वॉल्यूम केते थिबो v1, मास केते थिबो m1, टेंपरेचर थिबो t1. जते बेले मैं को हीट करबी, what will happen? Due to the transfer of heat energy, water will start boiling, and after boiling it will convert into vapors. During vaporization, some amount of water will be removed from the container in the form of vapors. तो boil हवा जोगु किछि water vapor form रे एठु बाहर जिवो. So some amount of water volume decrease करिवो. That is I am taking V2 and we know that V1 is greater than V2. जेहेतु volume decrease करूची, mass भी decrease करिवो and also mass decreasing. मुझे तबले बुनसन बर्नर रे को हीट करली, टेंपरेचर राइज करितला, एको हटे देले टेंपरेचर चेंज हबो, डिक्रीज करिवो, that is T2. So T1 is not equal to T2. Now a case what will happen? You can see during the process mass of the or matter of the substance get changed with the surrounding. किछि matter exchange हला surrounding सहित in the form of vapors, and energy gain hela then lose hela. There is exchange of energy also. So जदि गोटे system रे both energy and mass exchange हुए ताहले ताको हमें कहबा open system. The system in which both energy and mass can be exchanged with surrounding is called open system. सही जदि मु यार फेस को क्लोज कर देबी, सील कर देबी, what will happen? During the transfer of heat energy or during the evaporation, the vapors may not be escaped from the container. ए केस रे हीट देला बेले vaporization रो जो vapors बाहरिबे से escape करि परिबे नाही. After cooling, I will find same vapors will be liquefied into the same liquid. ता माने जते बेले हम क्लोज करूची V1 equals to V2. So mass will also remain constant. M1 equals to M2. तो क्लोज सिस्टम रे वॉल्यूम और मास चेंज हबो नाही, बट टेंपरेचर राइज हेतला प्लस फॉल हेतला, सेत में एठी एनर्जी एक्सचेंज हे परिबो. एठी एनर्जी एक्सचेंज हे परिबो. तो फर्स्ट केस रे बोथ एनर्जी और मास get exchanged. It keeps energy. So the system in which only energy can be exchanged between system and surrounding called closed system. Now, मुझे यदि यार surrounding को cool रे बा insulated करी देबी, we know that temperature cannot be transferred through a insulated system. तो insulation कले heat energy भितर को जाकर there is no exchange of heat, ताले को हमें कहबा isolated. Nothing can be exchanged. So if the system, in the system in which, system in which both energy and mass cannot be exchanged with surrounding is called isolated system. हमें डिस्कस करवा थर्मोडायनामिक प्रोसेसेस। Now what is first is isothermal process. Now हमें माने कि चलिबा जे आइसो माने कांस्टेंट, थर्म माने हीट और टेम्परेचर। जदि कोनोसी प्रोसेस टेम्परेचर रिमेन कांस्टेंट, first we will discuss about isothermal process, system in which temperature remain constant is called isothermal process. जदि कोनोसी सिस्टम रे टेम्परेचर समान अछि, then we can write that the initial temperature T1 equals to the final temperature T2. For that, change in temperature is equals to 0. जदि हम आइसोथर्मल कथा डिस्कस करिबा ता केस रे चेंज इन टेम्परेचर विल बी 0. Now we remember that heat energy can be exchanged that is dq, or we can write del q, cannot be 0. Now second one is isobaric process. जदि कोनोसी सिस्टम रे प्रेशर कांस्टेंट मेंटेन करा जाए, then we will say that it is a isobaric process. System in which pressure remain constant is called isobaric process. जदि कोनोसी सिस्टम रो प्रेशर कांस्टेंट अछि, then we can say the initial pressure P1 equals to the final pressure P2. For that purpose, change in pressure, that is del P, is equals to 0. Then we will discuss about isochoric process. Isochoric process, same here, core means volume. System in which we maintain or we take the volume remain constant is called isochoric process. जदि कोनोसी सिस्टम रे हमें वॉल्यूम को कांस्टेंट बोली ऑब्जर्व करू बा मेंटेन करू, ताहाले ताको हमें कहिबा आइसोकोरिक प्रोसेस. For isochoric process, initial volume V1 equals to final volume V2, then del V equals to 0. We have to remember these conditions. Now we will discuss about adiabatic process. Adiabatic process, system in which heat energy cannot be exchanged between system and surrounding is called adiabatic process. A case रे we will write del Q is equals to 0. There is no change of heat in system, but temperature can be changed. Temperature of the system can be increased or decreased depending upon the type of reaction. जो सिस्टम भीतर हीट एनर्जी एक्सचेंज होबो नाही, दैट इज del Q 0, बट सिस्टम रो टेम्परेचर राइज करि पारे, फॉल करि पारे डिपेंडिंग अपॉन द टाइप ऑफ रिएक्शन, वेदर द रिएक्शन इज एंडोथर्मिक और एक्सोथर्मिक. About macroscopic property. So whenever we discuss about some bulk behavior of the matter is called macroscopic property. So we can say bulk behavior of matter को हमें कहूँ कौन macroscopic property. तो next classified macroscopic property is classified into two types, that is extensive property, extensive or extrinsic property. Intensive or intrinsic property. So we will start with extensive property. Now, anything that depends upon any property or any macroscopic property that depends upon the amount of substance present in the system is called macroscopic property. Extensive property. What we can say, consider it have initial mass m1, initial volume v1, initial density d1. Now, middle portion ru equal to pieces to get this one. Now tell me what will be the mass? Yaro mu adha karichi, so I will get that m1 by 2, that is my m2. Volume will remain also, get half v1 by v2, but density will remain same. Now जेतेबेले मु किछि property discuss करली, I found that some property get changed when I cut this into two equal halves, but some property will remain same or unchanged. जो property या एको अधा कला पर चेंज हेले ताको हमें कहिबा एक्सटेंसिव प्रॉपर्टी. जो प्रॉपर्टी चेंज हेले नाही सेमान को हमें कहिबा इंटेंसिव प्रॉपर्टी. सो एक्सटेंसिव प्रॉपर्टी अंडर रे हमें लिखि परिबा एग्जांपल्स दे परिबा. दैट एक्सटेंसिव प्रॉपर्टी रे एग्जांपल्स हले मास, वॉल्यूम, gives free energy, G, enthalpy, H, internal energy, U, entropy, S. So these are some extensive properties. Now what about intensive or intrinsic property? Macroscopic property which does not depend upon the amount of substance present in the system. Same substance को यदि मैं two equal halves कर देवी तो density, taste, concentration will remain same. That's why they are called intensive property. Now what are the intensive properties? We can write examples: temperature, boiling point, melting point, density, molar heat capacity, refractive index, and etc. So these are called some of intensive properties. Now we will discuss about state variables. We know that there is three types of physical state of matter exist: solid state, liquid state, gaseous state. Some variables such as pressure, volume, temperature that defines the physical states of matter, whether they will be in solid state or liquid state or gaseous state. those are called state variables. So normally pressure, volume, temperature are called state variables. Now we will discuss about state functions. What are state functions? State functions are, these are basically the functions which defines the physical state of matter depending upon the state variables such as pressure, volume, temperature. So some of the state functions are Gibbs free energy, enthalpy, internal energy, composition, entropy, then composition, we will get Busa. These are also the examples of extrinsic property. So we can say all the state functions are also extrinsic properties. And the more important thing is that state functions do not depend upon the path followed by the system. It only depends upon the initial value and the final value. That's why we cannot determine absolute value for a state function. Now we will discuss about what are path functions. Any function that depends upon path followed by the system is called path function. Normally, work and heat energy are known as path functions. Work is of two types. One is electrical work, another one is mechanical work. Electrical work को हमें लिखते हैं del G minus del G equals to NFE, while mechanical work is also known as pressure volume work. It is classified into two types, that is on the system work done on the system, work done by the system.